Welcome again, everyone, and thank you for joining us on today's webinar, Reducing Chemical Injection Costs with Confidence in Your Measurement. I'm Allison Sterling, Marketing Manager at Emerson Micromotion, and I'm pleased to welcome you to our Emerson Flow Expert webinar series. Before we begin today, I wanted to take a moment to acquaint you with your webinar environment. On your screen, you should see a presentation window on the left side, a Q&A chat window in the upper right-hand corner, media player controls, and a resource box with related content that you can view and download during the event. You can resize, move, or minimize any of these windows during the event to fit your viewing preferences. And so, for example, if you'd like to view the presentation window larger, you can actually maximize that and it'll fill your screen. At the bottom of your display, you'll see a row of icons that give you added capabilities, such as you can share the webinar via social channels, or you can request a visit from our Flow experts. Throughout the webinar, we encourage you to interact with our speakers by typing in questions and comments using the chat panel, and we'll collect all these questions and we'll address them at the end of the event. We are also recording today's webinar, and we will make a link to this recording available to you 24 hours post-event via email. On today's webinar, we are lucky enough to have joining us three outstanding presenters. We have Laura Schaefer, the Director of Oil and Gas Business Development for Micromotion, who has over 13 years of experience in the oil and gas industry. We also have with us Tim Drost, Global Product Manager for Micromotion, who has been with Emerson for over 11 years, and Anthony Hartman, Global Marketing Director of TestCon, who has been with Emerson for over 10 years. Welcome to all our speakers. I'll now pass on to Laura. Welcome, Laura.
Thanks, Allison. Good morning and good afternoon to all. I want you all to take just a moment and ask yourself, how much does your company spend every year on chemicals? For most, chemical injection is a sunk cost of production, and it's a cost that's hard to tackle because few of us are chemists, and challenging both the dosage of chemical and the amount spent on chemical is very difficult for us to do. But in today's low oil price environment, a critical examination of your chemical injection system and practices may yield tremendous operating savings. Let's first consider a single platform and the annual amount spent for injecting chemical in 6 to 8 wells offshore. We'll follow on the next slide by looking at a single onshore well. So for those of you working onshore, hang tight. We'll get to your more down-to-earth figures next. But for this representative offshore platform, 4 to 6 chemicals would be injected per well, and that would include scale inhibitor, wax inhibitor, corrosion inhibitor, as well as monoethylene glycol or methanol for hydrate inhibition. In this case, for this platform, we would inject over 9,000 gallons of chemical per hour for 8 wells. 9,000 gallons of chemical per hour. So in total, this hypothetical platform would consume $175 million in annual operational costs just in the chemical alone. I haven't even factored in maintenance costs. Out of that $175 million, 10% of that alone is spent on hydrate prevention, just the hydrate prevention itself. And if all that chemical is injected at only 1% error, that's still potentially 800,000 gallons of additional chemical injected in just a single year for a single platform, just due to uncertainty in the measurement and control scheme being used. And I'll tell you, talking to many customers, 1% error is not where most folks are operating. Chemical injection represents a tremendous cost, and in today's environment, such an operational cost deserves more scrutiny. For those onshore, this is much less dramatic as far as cost, but perhaps even more prevalent. Most onshore wells are racking up their own chemical injection bills without oversight. Most folks have just a tank sitting there with a little pump, and that pump is kicking out chemical, and very, very little oversight to am I over-injecting or under-injecting. So taking that single onshore well that produces, say, 2 million scoff per day, and requires about 273 pounds of methanol per million scoff per day. That requires an injection rate of 3.42 gallons per hour. but say my pump's not that accurate, I mean 3.42 gallons per hour, I'm just going to round up to 5 gallons per hour and set my pump there. Because that's all the more accurate my pump is, that's all the more I trust my pump. At 50 cents per gallon for that methanol, that's still $6,570 per year wasted due to lack of accurate measurement and control on that unit. While $6,570 is a relatively small amount, consider that many operators have over 1,000 wells operating at a time, and that $6,570 wasted becomes $6.57 million wasted per year. Chemical injection as a cost of doing business has a tremendous impact on your bottom line. Let's take a look at the state of the art and what's preventing producers from being more exact, and look at ways to take back control of chemical injection and give visibility to our operations on exactly what we spend on chemicals and why. I'm going to continue by highlighting challenges with traditional equipment used, and then I'll be followed by Anthony and Tim discussing how to better monitor and control with Emerson products. So, fact that chemicals are a necessary expense. Without these preventative chemicals, scales and waxes could plug tubing, shut down facilities. Hydrates could block production, costing up to $1 million per day and shut in production as you have to take the time to dissociate that hydrate safely. Without corrosion inhibitor, complete loss of a well or infrastructure could occur over time. With such severe consequences for under-injecting chemical, producers consistently inject more than recommended every time. In one case, I personally worked with a producer who was over-injecting demulsifier by 50% just to be certain that an emulsion didn't form and shut down the production facilities. 50% over-injection. So think for a moment and ask yourself, and I'd encourage you to be interactive here on this little question here. Compared to the manufacturers, the chemical manufacturers' recommendations, how much does your company typically over-inject on chemicals? I'll give you a moment to respond, to interact here. Choose a radio button, and we'll take a look at the responses here in a second. All right, responses are starting to come in. And it indeed looks, we've got enough coming in to keep going. It indeed looks like most of you are at 10% or 20% or more. That's a significant amount of cost. The annual cost of over-injecting for a flow meter run at 20% additional could be as high as $400K. I just ran an example here on the right for the amount of chemical over-injection versus the cost per year. I used more of an offshore type well here. This was a 10,000 barrel a day well. I was using $50 per gallon on that chemical, and then I was injecting at a concentration of 0.25 gallons per 1,000 gallons produced. That's a modest analysis for an offshore well, and that single well at 20% over-injection would be $400,000 a year. That over-injection also has other potential consequences. One, additional trips to the field to replenish the chemicals in the storage tank, whether that be onshore and just bringing more totes more frequently, or whether you're dealing with offshore logistics and trying to get supply vessels arranged and sending more chemical out that way. That additional chemical can also have an adverse impact on your downstream processing or downstream treatment programs. In the case of crude oil shipments to refineries, methanol concentrations over 25 parts per million are not acceptable to some refineries. And when you're over-injecting, for example, your hydrate inhibitor, you can actually impact the value that you get for your crude. So we're over-injecting. We're over-injecting by a lot. That 10 to 20%, that's a lot of money that's wasted every year. So why are we over-injecting? What are the primary challenges that you face with your chemical injection system that prevent you from injecting chemical at the recommended quantities rather than over-injecting? So I encourage you again to interact here and see if your challenge is here listed as far as what's the challenge that you face with a reliable chemical injection system. We'll give a few moments for folks to respond back. And so far it looks like, well, oh, no, a couple interesting, yeah, overwhelmingly it's injecting the right amount of chemical. And that's understandable because there's a lot of challenges that we hear from the customers that we talk about on the reliability of the system. And first thing that we hear about is injection rate drift. Whether that be mechanically from the pump or valve controlling flow, these items, each of these, the pumps, the valves, they tend to change their rates based on back pressure in the system or wear of their parts and seals. As one operator in the Gulf of Mexico noted in the quote on the left, they needed to employ one technician just to monitor and adjust chemical injection rates every 4 hours because the valves controlling that flow continued to drift all the time. Now, that's a mechanical drift. There's also chemical drift. So as your chemicals change in temperature, very often they'll change dramatically in viscosity. And that change in viscosity for traditional flow meters results in a drift of the actual chemical injected versus indicated rate. If you're using some sort of IRCD or some sort of differential control, change in the product density with temperature can also impact the amount injected. So because you're uncertain on the amount injected, typically you're going to inject over the target rate. Another challenge that we hear about are plugging issues, whether that's due to chemical quality or precipitates forming in chemical as it's exposed to the atmosphere, or due to failed filters. Plugging can result in under-injection of chemical and potentially major shutdowns. Some of this equipment is also very, very maintenance intensive, especially at startup and shutdown. Another quote on the left-hand side there, a North Sea operator noted that the injection control devices experience constant failure due to frequent startups and shutdowns. If startups and shutdowns are handled just a little bit incorrectly, that can cause complete failure of that device. Another challenge noted is the wide turn down required over the life of the well. Many valves and flow meters have very limited turn down that does not serve the range of expected flow rates over the life of the well, particularly as the asset declines or enters secondary or tertiary recovery. Oftentimes you'll have to pull out those devices and replace them because they're not sufficient to the turn down available. And lastly, those working offshore are always challenged with space and weight for their systems. Space and weight is a premium, so any reduction in equipment size and weight can result in significant upfront savings in the installation itself. So I've talked to the cost of the chemicals. Whoops. What if you could improve system reliability, be confident in your chemical injection system, and know that you're injecting exactly what the equipment says you're injecting? Because you've improved reliability, you can begin to reduce the chemical costs and only inject what you need to inject. Take those lab reports or chemical provider recommendations and comfortably and confidently inject just what you need rather than over-inject for comfort. And once you've improved the system, reduced your costs, you're also increasing your operational efficiency, reducing the number of folks that you need to check on these things, reducing the logistics to resupply chemical to each of your locations. Subsequently, reducing safety risks as you have fewer folks driving from well to well or shuttling chemical back and forth to your offshore platforms. So how can Emerson help? And I'm going the wrong direction, sorry. So how can Emerson help? Well, we're sensitive to all of your concerns, whether offshore or onshore, including space and weight, the more challenging conditions that some folks are seeing as far as higher temperatures, higher pressures, and keep your projects on time, on track, and on cost. So we do that by offering both monitoring and control solutions for chemical injection that will dramatically improve the reliability of your chemical injection system and provide the certainty of injection needed to reduce the amount that you overinject, dropping operating dollars to your bottom line as soon as possible. The graphic here shows just one example of an offshore installation arrangement, this one with a single chemical and multiple drops to multiple wells. However, the control valve plus Coriolis flow meter for monitoring can be used in any well arrangement, onshore or offshore, in wells with pressures from a handful of psi up to 15,000 psi surface injection pressures. I'll now hand it over to Anthony Hartman to explain how the Emerson flow control valve delivers on reliability and certainty.
All right, thank you very much, Laura. Let's continue on. We have this poll question. How do you typically control the amount of chemical injected? 4 options: pump strokes, valves, GoFlow AmFlow IRCD, or a TESCOM flow control valve. I'll give you just a few moments to respond. All right, they're flowing in. Give another moment or two. Okay, kind of as expected here. You can see over half of the attendees are looking at how a pump works, or a metering pump, which is pretty typical. Tend to be a little more costly and complicated to maintain, and then pretty even spread on the next 3 options. So as you just heard from Laura, flow assurance is really a very critical component of the design and operation in your offshore production facilities and the onshore facilities. With cost of controlling the hydrates, corrosion, scale, and wax in excess of 10% of the operation cost, it's even more crucial for operators to maintain the accurate control of these injection rates. Traditional methods, as you saw in the poll here, have large amounts of variation, low repeatability, and tend to have injection rate drift, which results in the operators having to increase the flow rates to make sure that variation never drops below the required rate. Variation in flow can result from the device design that does not account for variation in other process parameters. The Gulf of Mexico operator that Laura quoted earlier actually dedicated one specific technician to just monitor and adjust these rates because of the poor consistency of the device. You can see that's an incredible waste of resources and money when there are much better options available. To bring your injection rate closer to the required rate, you need a precision chemical injection flow control that retains its consistency regardless of downstream pressure fluctuations or other changing conditions. This helps to avoid excessive overinjection and underinjection and waste of money and chemicals. The current flow control options have consistent issues with these maintenance and reliability. Quote from the North Sea operator mentioned earlier highlighted issues with the reliability of the traditional method of flow control. Complex designs resulted in the poor performance in regards to plugging off and long maintenance procedures causing extended shutdown periods. So wouldn't it be nice if there was a better option? The TESCOM 56 series chemical injection flow control devices are exactly that. The TESCOM 56 series devices provide consistent flow of chemicals to your production infrastructure no matter how the conditions change, allow you to optimize the chemical usage to prevent problems associated with underinjection and the waste associated with overinjection. They also reduce operational and maintenance costs while increasing safety by extending the service life and being extremely easy to maintain. The TESCOM 56 series was designed specifically to solve the issues on the offshore facility. They're fully tested to perform throughout the life of the well, as shown on the chart in the lower right. The orange line on the graph, if it's not too small to see, represents the declining pressure of the well over the life of a well. And the green line shows that regardless of the well pressure and flow demands, the TESCOM 56 series can deliver a consistent and accurate flow rate. The 56 series can cover a wide range of needs for all operator systems and chemical types. The series has a manual controlled device that is purely mechanical, capable of consistent, extremely low flows of 0.0003 gallons per minute to moderate flows of 2.8 gallons per minute. The proven design does not plug up like the competition and is extremely simple to maintain, ensuring you can run longer and be down shorter if you do have a failure. For any operators that need higher flow rates, expect to have a higher rate of accuracy, or prefer to be able to monitor and adjust from a central control room, TESCOM offers what we call the active control device. The active control flow device integrates a PID controller with a pressure regulator. The PID controller takes a signal from the flow meter and controls the flow rate using a local closed loop. Connection to a computer or control room is actually only necessary to change the settings. The TESCOM 56 series active control device will automatically compensate for any change in inlet pressure, outlet pressure, flow demand, temperature fluctuations, or any other anomaly in the system, and provide accurate chemical flow rate control. It is capable of taking any flow meter signal, but has been specifically designed and tested to integrate with the micromotion Coriolis flow meters. So at this point, I will turn it over to Tim, and he'll tell you a little more about these meters.
Thanks a lot, Anthony. So, like before, the first thing I'd like to do is start off with a poll question. So, I'm curious to know, how do you typically measure and verify your chemical injection today? And as you see, you have some options here: pump strokes, a turbine or a PD meter, tote tank volumes, a Coriolis meter, or you're just not quite sure and you just trust your chemical provider. All right, looks like we got a pretty good poll in there. So it looks like a lot of people are using either the tote tank volumes or a turbine PD meter. Pretty good spread though too. Some are using pump strokes as well. So what I want to do is kind of talk about Coriolis meters and how they can help measure your flow. So what are the benefits of measuring flow with a Coriolis meter compared to other technologies? First, Coriolis meters are extremely accurate. For example, our Coriolis meter can claim a mass flow accuracy of 0.1% of flow rate. The meter is also tremendously repeatable. This means that you're able to measure and account for all the chemicals that are being used to a high level and can drastically reduce overdosing, like Laura mentioned earlier, and ensure that the proper amount is being delivered every time. Next, unlike other meters like positive displacement or turbine, Coriolis meters have no moving parts. This means there are no moving parts that wear out over time or need replacing. The lack of moving parts greatly reduces the need to stock spare equipment for maintenance. It also helps to ensure the downtime is reduced and can drastically lower your operating costs. Finally, Coriolis meters are true mass meters. So mass meters measure the amount of flow regardless of the fluid properties. This is not really true for volumetric meters, which have errors associated with changing fluid characteristics like pressure or temperature. Also, those meters need to be calibrated directly to the fluid being measured in the process, and that's not really true for micromotion meters. Our meters, or mass meters, provide an accurate measurement, even if the fluid characteristics change, providing certainty that the flow rate's correct. In fact, you can reuse a micromotion meter on a different application or chemical without even needing to recalibrate the instrument. But Coriolis meters don't just measure mass flow, they're also extremely accurate densitometers too. And why is density important? Density is a great quality control measurement. As a product changes its composition, its density also changes. And users are able to check a density or concentration measurement to ensure that they're getting the proper chemicals delivered and that you're paying for what you're getting delivered and you're putting the right chemical downhole. Additionally, the density measurement can be used as an interface detection. And you can set up a concentration limit for your fluids and know that the chemical concentration or fluid properties have or haven't changed over time by using that density interface. Coriolis meters are also a good temperature reading too. The measurement is plus or minus 1 degree Celsius accurate, so the Coriolis meter can either be used as a primary or even a redundant temperature measurement for your system. Finally, micromotion meters also have a diagnostic called drive gain, and drive gain is really important because it gives an indication of the fluid state going through the meter. If there's a process upset, like the presence of entrained gas, the drive gain can notify a user that the process is now in an error state, and someone should look at eliminating the unwanted gas in the system. Micromotion also offers a diagnostic called smart meter verification. Once again, Coriolis meters have no moving parts and are not expected to degrade over time. That being said, some users still question whether the instrument's working correctly, or they may have internal procedures where they have to calibrate the equipment over a given time interval. Smart meter verification, or SMV, is a quick and easy tool to be run by a touch of a button to give full confidence that the meter is still in its factory condition. SMV works by establishing a baseline at the factory for a new meter. The baseline is stored in the electronics and can be referenced at any time in the field. Once in the field, a user can run SMV and compare its present value to its original baseline to see if there's been any changes in the field. So it's a really great diagnostic that's unique to micromotion, and it can be used as a great way to extend or eliminate calibration intervals and give confidence that the meter is still operating accurately in your process. So just want to go over a quick results slide here. So this slide here is illustrating a few success stories from our customers that have used our meter to better account for chemical usage. So on the left, one user was able to stop their overdosing of chemicals and reduce their chemical spend by over 40%. And on the right-hand side, we're highlighting just a benefit that one of our users seen by moving towards Coriolis meters and now has a more accurate and repeatable measurement. So with that, I'd like to pass it back over to Anthony to look at some of the new products that have been introduced for the chemical injection applications.
All right, thank you, Tim. So I mentioned in my previous section, talked about the 56 series Testcom devices. And so what I'll do on the next two slides is to just give a little bit more of an overview so you can understand kind of the high-level technical portion. And if you have any questions, feel free to submit questions or come to our website after the webinar is complete. So the 56 series active control device is, like I said, a combination of a PID controller and regulator. The regulator will be specifically selected based on the pressure and required flow rates of the application and system. The PID controller itself has been used in many industries globally for well over 30 years and is really able to be tuned to any type of system configuration, any chemical injection skid configuration, or any plan or operator specific system. It can run remotely or be connected to a central control system if you need the feedback or want to change it remotely. It does require a power source and a pressure supply to operate and control the regulator. There's hazardous location options and stainless steel options if you need the installation requirements for the offshore corrosion or the hazardous location. The controller itself has a plus or minus 0.1% on repeatability and accuracy, and can sample from a flow meter at up to 25 milliseconds. So it's very accurate and repeatable, and does a very quick sampling and adjustment. But one thing to note with the system accuracy is it will depend on what the accuracy of the signal being fed to the controller. For this is one of the reasons we actually recommend, and we've tested it with the micromotion meters to ensure the accuracy is at the peak and gives you the best return on investment. The second part of the 56 series was the manual control devices. They're extremely reliable and effective. They are capable of an ultra low flow capability without having the plugging issues, which makes it a perfect choice for an installation that cannot utilize our active control device. It's much smaller than most of the alternative devices like pumps and some of the other flow control valves, and it's much simpler to maintain in this small package. Available in a wide range of materials and different installation orientations, flanges, and different panel mounts and things. And with that, I will turn it back to Tim, and he'll give you a few more details on the micromotion meters.
Great, Anthony. So here's a look at some of the common flow meters that we sell into chemical injection applications. As you can see, we have various different meters for different flow rates and pressure ranges. The variety of our product offering helps ensure you're getting the right product for your process. I do want to highlight a couple of the new products that we've introduced specifically for these chemical injection applications. So first, the F100P is a 1-inch high-pressure meter, and it's a great solution for measuring fluids like hydrate inhibitor that Laura mentioned earlier. Also, we will be releasing a 15,000 PSI meter called the HPC010P that will be available this summer. So we're seeing a lot of more processes designed to this higher pressure range, and this meter is really breaking the bounds of Coriolis measurement, and it should be a really good solution to applications like corrosion inhibitors. So I want to highlight some of the recent testing that we've conducted on this new HPC010P, and this was done at the TestCom flow stand with our friends down in Elk River, Minnesota. So this slide here is showing the setup of the facility. So here we have the HPC010P in the front of the picture, which is our unit under test. And in the back of the setup, we have another one of our Coriolis meters, the CMFS sensor, and it's used as the reference meter. You'll also notice there's a needle valve that can be used to help control the flow and pressure of the setup. And the process we ran for the test was a water and glycol mixture. And we're able to bring the whole accuracy of the setup down to about 0.5% accuracy at the pressure ranges of 15,000 PSI. So here are the results from that test. So what we're displaying is the temperature and flow rates for the 2 meters under the various pressure ranges. And at the very bottom of the graph, we're tracking the pressure of the process fluid. And you can see from the pressure that it's being increased in step intervals from around 5,000 to 15,000 PSI. And highlighted in the orange here are the flow rates of the 2 meters across the various flow ranges. And what you may notice is both the flow rates of the HPC010P and the reference meter are extremely similar and are on top of each other. So it's actually pretty tough to distinguish the 2 meters because they track so well. So the meter was, performed really well and is an excellent solution for these applications if you're looking for an accurate and repeatable measurement at 15,000 PSI. Micromotion also offers a wide range of transmitters to meet the needs of your process. So what we're doing here is that on the top of the screen we're highlighting our new 5700 transmitter. So this transmitter has a lot of flexibility in channels. So we have up to 5 input and output channels, and also it's offered in a wide range of digital protocols such as Foundation Field Bus, HART, Ethernet IP, and Ethernet TCP IP. We have other transmitters too. So we offer a 2-wire transmitter. So if you're really concerned with wiring costs, this is a good solution for you. We also have compact transmitters if space and weight considerations are most important. And finally, we do have stainless steel transmitters for offshore applications. So whatever your connectivity needs, we really have you covered. Here, just want to highlight that we've developed a return on investment calculator. So this tool asks for various inputs on how your process is run today, and it's really meant as a means to look at where your capital and operating expenses are going. The calculator will also give you a good idea of what you're leaving on the table from a money standpoint and how our products can be, what the return on investment of the products will be to help justify them. So the calculator, you can see the link at the top of the page here, and it's actually still, it's also available in your resources list on the WebEx. So with that, I'd like to thank you for your time today and pass it over to Allison, and we can go over any questions at all.
Perfect. Thank you so much, Tim, and thank you very much to all of our speakers. for all this great information. As to mention, we're now going to open it up for questions. So as a reminder, please use the chat window to ask your questions. And it looks like we already have some in the queue.
Absolutely. Thanks, Allison. So the first question that we have is regarding trade-offs for Coriolis meters at very low flow rates where pump pulsations may create large errors in reading. We've had questions about pump pulsation quite a bit, and whether a dampener is required and how it's going to impact the flow measurement. I'd state that dampeners, first and foremost, your primary reason for putting in a dampener wouldn't necessarily be for the flow measurement itself. The dampeners are recommended to protect your pump and the life of the efficiency and the life of your pump. Dampeners reduce friction losses on your pump suction and make your pumps more efficient, enhancing life of check valves and improving volumetric efficiency. They also cut down on pipe shaking and vibration, increasing the life of the piping and valves. As far as the accuracy of your measurement, a pulsation dampener is going to help smooth out the measurement that you see out of your Coriolis meter. A Coriolis meter itself is very accurate, and it's going to show in the reading all the results of that pulsation. And certainly having a pulsation dampener in line will help smooth out that reading. And it's going to help also if you've got some feedback loop like what we're talking about. It helps ease the PID integration of that loop. So a pulsation dampener isn't specifically required for a Coriolis meter. A Coriolis meter is still going to give you very accurate measurement. It just may give you a measurement that you're not comfortable seeing as far as seeing that pulsation and having your control system see that pulsation. When you're looking at very, very low flow rates, I'd say that we've installed a number of very small Coriolis meters, that 1/10 of an inch meter, that CMFS 10P. We've installed those in a number of corrosion inhibitor injection, chemical injection applications, and had very, very good measurement even at very low flow rates, particularly when that pulsation dampener is installed. So that hopefully that's answered that question. Next question is, what is the minimum flow rate measurement for a Coriolis meter? Tim, product manager, go ahead.
Yeah, sure. So we did show on the slide that each meter has a different turn down range. So many of them, I didn't maybe highlight it too much in the presentation here, but Coriolis meters are known for their wide turn down. So some of them are 20 to 1 turn down. If we're looking at the 15,000 PSI meter, what we claim is a 10 to 1 turn down. So the low range on that would be 22 pounds per hour. Now, do realize that that is the flat spec of the meter, where you're going to see, the stated 0.2% accuracy. But you can operate below that flow rate. There's no minimum flow rate like some other volumetric meters where it'll stop reading. So you'll still be able to go well below that one. It's just the accuracy will start not being 0.2, will be outside of the flat spec.
So yes, we've quoted or looked at that HPC 10 for significantly lower flow rates. It's just at that point, if you're going significantly below that 22 pounds per hour, then you're looking at, say, 2% accuracy, 3% accuracy, etc. So if you're looking for a reliable flow meter at those extremely low rates, you could still consider the Coriolis. We just work with you to let you know what the accuracy would be at the flow rate that you're looking at. Next question that I've got is, we are using 3/8 inch stainless steel tubing for our chemical. Do you make a Coriolis meter that small? Absolutely, and we go smaller still. So please, if you're interested in learning more, definitely just drop us a note. Let's see here, Anthony. There's one in your bucket. You want to?
Yeah, I can answer this one here. So the question is, can the 56 series valve operate other applications besides chemical injection? So the response to that is absolutely. The active control version in the 56 series can really be configured to control anything for flow rates, pressures, and temperatures. It's really just how we set up the controls and what type of regulator we put underneath it. For the manual valve, the 56 series manual side, it is really a flow rate controller, so it can control any type of flow rate for gases or liquids. In this case, we're just using it to meter the chemical flow rate, but it can absolutely be used for anything. So if you need more information, just send me a follow-up note or take a look on the web and then contact us.
We've got one here asking how we could integrate this system when using a subsea CIMV. Just to comment here, this system that we've been talking about, I said you could use it with just about any arrangement. These products are not subsea at this time, and so as far as integration with the CIMV, to the extent of the knowledge that I have about a CIMV, you're not able to integrate our equipment there. This is all topside equipment that we've been talking about throughout this talk.
Another question here asking about the maximum viscosity that a flow meter can handle. So Coriolis meters are unique in that they don't have a maximum viscosity that you can handle. Usually biggest consideration is going to be the pump that you have in there, and if you're able to flow it through the flow meter, obviously there's a associated pressure drop across the flow meter, and any of our sizing calculations that any of our sales reps or I would be happy to do is can size up the application and let you know what the expected pressure drop would be for that flow meter at a given viscosity.
Okay. Couple more for you there, Anthony.
Yeah, so we have a question that says, what division does the TESCOM regulators come under? Who sells it? The TESCOM regulators are part of the company we call Regulator Technologies, and there's specific distributors throughout North America. You can go to the web page and there should be a contact us link to find the local agent, or you can send me a note with your contact information and I can help put you in touch with the right people. Let's see here. And then there's one other one here. So it says, I work in the geothermal industry. Can your system keep scale and corrosion inhibitor concentrations constant regardless of pressure, temperature, flow, and other process changes? It shouldn't be a problem with the active control, because that can take readings from the system, and then it will automatically compensate no matter what your pressure and temperatures are. So if you have some specific ideas, send me a note and we can put you in contact with some of the system design engineers to talk through and make sure we can meet it. But it sounds, from a high level, it sounds like it should not be a problem. And back to you, Laura. Any others?
Let's see here.
Looks like all the ones here are answered.
Yep. I've got one other commenting back on that CIMV, and I think we'll go ahead and address that one offline with the customer and get some more experts pulled in. Any other questions with that? I really appreciate everyone's attendance here. Hopefully that you learned something about how you might be able to reduce your operating costs around chemical injection. And as always, if you have any questions, don't hesitate to drop us notes. We're always happy to answer.
Yeah, and just to reiterate what Laura just said, if you have any questions, please don't hesitate to contact us either via the button at the bottom of your screen, or we'll also, like I said, be following up tomorrow with a link to the recording of the webinar, so you can always contact us through that. So we want to thank you again for joining us today on the webinar and for all the great questions we received. On behalf of our guests, Laura Schaefer, Tim Drost, Anthony Hartman, as well as everyone at Emerson Process Management, we thank you for joining us and taking the time to view our webinar, and we hope you all have a great day. Thank you.